If you were to go to university and to talk to someone who has studied about life their whole life and have a doctorate in physics, and you asked them, what is life? You might get an answer that would be kind of funny, where they might laugh a little and be like, all right, what do you want to know? Because when it comes down to it, we don't really understand exactly what light is. There are still a lot of mysteries waiting to be uncovered about what the nature of light is. So if you go to college and you study physics, you might one day be the person to discover what light really is, which is pretty cool. There are mysteries waiting to be discovered still in science, which is one of my favorite things about science. But having said that, we do know a lot about light. And if I shine it on the CD, look up at the ceiling, and what do you see? Yeah, you see a rainbow. The white light is being refracted and scattered into a rainbow. And we're going to do today something that I think is even cooler. We're going to take colored light and combine it to make white. So here, the light looks green, right? And if I turn off this green one and turn on the red one, we see red light. And now watch closely, watch especially the letters for the word light. If I turn on all of these, red, blue, yellow, and green, now it looks white. But I'm not actually putting any white light onto that screen. I'm shining red, blue, yellow, and green light onto the screen. And I can sort of prove that to you by putting the letters forward so that you can see the shadows, because the shadows are going to look really cool.
Your shadow is cool. Oh, your shadow.
Yeah, my shadow looks pretty amazing too, because I am not standing in white light, I'm standing in colored light. Pretty cool, right?
That's awesome.
It's very pretty. And if we turn off two of these lights, so I'm going to real quick turn off the blue and the yellow, now we just see red and green shadows. And they're offset because the lights are farther apart. And so here on the letter L, we have both red and green light hitting, and they interact with each other. Remember how I said that light's a wave? And the red light has a different wavelength than the green light. So when they overlap, this looks pretty close to being white, right? If you're looking just at the letter here. But then behind here, only the green light is hitting this part of the sheet. Only the red light is hitting this part. And then where they overlap, we don't have green light or red light hitting. And so we get the shadow that looks more like a true shadow. So pretty cool, right? Let's take a look at some of the different combinations. So this is red and green. How about we try red and blue? There's red and blue.
Oh, it looks like a airhead.
And then let's do blue and green. And it does look just a little bit yellow over here. And it also looks closer to what we would see if we just had a white light, right? If we had two white lights, because the blue and the green are more similar. And now we'll do yellow and green.
Looks like a mini.
And then we'll do yellow and blue, your school colors.
Yay!
And last, we're going to do yellow and red. Now, this one's a bit of a surprise because we have yellow light coming and red light coming, but our shadows look
green.
kind of turquoise or green and then sort of pink.
Like a purple.
Or almost a little purple. They look different. It looks different to different people. And here's another cool thing about light. When we see something, what we see is a combination of the wavelengths, the actual light that there is coming, and our eyes. And different people can look at the same light and see different colors. This is especially obvious with something like red-green color blindness, where I look at red and I look at green and I see two very different colors, but someone who's red-green colorblind, they look at red and green and they see the same colors. But we can see it on a different scale with an example like this. When I show this to classes, a lot of times some people will think that this is green and other people say, are you kidding? That's not green, that's very turquoise. It has a lot of blue in it. And this pink one too looks very purple to some people, and to others it looks like it's just more of a pink and has more red tones. So this is a color wheel. And because I used markers instead of printing it out with color, it's not quite true colors. So this red is not a true red, it's kind of a pink red, right? And same thing with, the purple and a lot of the other colors, they're not quite true colors. And because of that, when I spin it, we're not going to have the same thing like we did with the sheet, where I shined all of the different colors of light and we got white. When I spin this, you're not going to see white, but it's going to get very close. It's going to be either a light green, a light orange, or some people see a light blue. So you might see orange or reddish or green or bluish, just depending on your eyes. Now when I spin this fast, I'm not talking about right here in the center, because it's not perfectly centered on the drill. The center part is going to look dark blue, and then here we have a rim of cardboard on the outside, and that's going to look dark, kind of a brownish. But in between the center and the outside edge of the circle, in this part, different people will see different colors once it starts going fast. So first, when I spin it slow, you can tell that there are a lot of colors moving around, right? Your eye still recognizes. It's just a whole lot of colors spinning. But when I speed up, it's going to change. All right, give me 5. 5. I'm going to do it again, but before I do it again, I want you guys to, let's do it by raise of hands, because if you all call out what you see, it's a little chaotic. But let's have you raise your hand if you saw orange, if it looked orange to you. All right, hands down. Raise your hand if it looked pink or reddish. Hands down. Raise your hand if it looked greenish or bluish. So this is really sort of cool. About half the class, half of you guys, saw more of the red and the orange tones, or kind of bordering on the pink, and then half saw the cooler tones, the green or the blue. Let's review real quick some things we learned about light, and then I want to tell you about a book order I have. So what did we learn about light in terms of how it travels? Does it travel as a
wave?
It does. It travels as a wave. And if the wave is going kind of gentle like this, does it have low energy or high energy?
Low.
Low, that's right. What if the wave is traveling with very short wavelengths and high peaks?
Fast.
Yes, it has high energy. Can anyone give me an example of a light that has a lot of energy? That's a fantastic example with your hand. What about by name? And a type of light that can give you sunburn, for example.
UV light?
Yes, UV light has a very high energy. That means that the wavelengths are short together, and it's going like this. What about a visible light that has the lowest energy?
Red.
That's right, red light has the lowest energy.
You're on the ceiling.
Am I on the ceiling? Can you guys see my wall? Yes. I made my colored lights by taking spotlights and then cutting a cereal box into a cylinder and attaching it with duct tape and putting a plastic tablecloth over the top. But a much cheaper and quicker way to do this would be to take a flashlight and then tape a colored balloon over the top of the flashlight. And if you would like to print out your own color wheel or other optical illusion discs like a Fenchner wheel or Bendman's disc, then you can check out on my Patreon page or my Teachers Pay Teachers account. I have worksheets and a whole bunch of resources and a lesson plan that go along with this activity. And as always, thank you for watching.